Hi everyone, today I'm going to show you how to download the NLDAS precipitation. In the last tutorial we have seen how we can process the NLDAS North American Data Assimilation Systems precipitation product using GIS software, right? So you have to open an account in this website. So I can give you the link in the description. You can find it and you can click it here, and then you can just open your account here, and then you have to verify your account, and after that you will be able to download it. So let's see how can we just download the NLDAS precipitation. Basically this precipitation product is known as MPE. It is a product from multi-sensor multi-radar system, and it is a combination of radar precipitation with the GIS precipitation, and the algorithm is developed from our laboratory. The professor from our laboratory, he has the main architect of this precipitation product. So let's see how can we just download or specify. Okay, so what do you have to do when you just open the account, and you will navigate to this directory in the website of Earth, in the website of Earth Data System, right? So you'll find a menu here. You have to click on the subset or get data, and then this window will appear, and here you have to specify your download time period. So let's click on this. So since in the previous model we have developed a HEC-HMS model for the Hurricane Harvey that occurred from August 25th of 2017 to 30th August 2017. So I'm gonna download the precipitation data for the same time period. So if you just click here, you have to specify the range of your year. So here that is 2017, and click on August, and it will show you the days, and then my download is from 25th of August to 30. So here I'm just specifying 2017 and August and up to 30, right? So the date is here, and now we have to specify the spatial subset. That means if I just click on this, it is showing the map of the world, and see it is highlighting the conterminous USA. That means we have data all over the USA. You can just zoom in, or you can select any state, or for this case I'm downloading the precipitation data for the whole USA. And now we have the variable. Previously I told you that this data format is a netcdf, so it is a network common data format. It is a like a multi-dimensional data format, so only one file can contain multi variables. For example, here we have APCP, that means it is a precipitation hourly total. kg per meter square means it is in millimeter, and then we have other variables like above ground convective available potential energy, and we have fraction of total precipitation, that is convective, but we don't need this one here. But what we need DLWRF, that means long wave radiation flux. We need it for computing the evapotranspiration if you use a Penman-Monteith equation, and the unit is watt per meter square. And we need also the short wave radiation, and we need, so I'm just selecting the precipitation. I'm selecting this long wave radiation, short wave radiation. I also need the pressure. I also need this one, SPFH. It is the specific humidity. It is like measured above the ground surface, which is the 2-meter height, and TMP means the temperature. It is also measured at 2-meter height from the ground. I also need the wind speed, UZRD. It is also measured at 10-meter height above the ground, and the unit is the meter per second. And now grid system. So I have a lot of grid here, but I'm not going to select any one because previously I mentioned that the grid is 0.125 degree by 0.15 degree. So let's select the file format. So there are two file formats here. The grid, it is the default format, but for this case I'm downloading this netstadia file. So after selecting this, see the get data button is activated. So if I click on this, so it will just show you the list of files, because this data is hourly basis data, so it will show you the link for all the files, all the individual files. So how many files will be there? We have 6 days of data, and since it is hourly data, we have 6 into 23. Now it is 138. The total number of file will be 138. So it is still just calculating the list of the files, and it is still checking if the data is available. And yeah, we have this up to 30th August 2017, and the hour is up to 2300, right? So if I just click on this download link list, it will download the list of all the files, basically the links of the files in a text format. So I'm going to download this text file here. Yeah, it is there. I'm just finding it from my download folder. I'm cutting it, and what I'm going to do here, see, I've already created a folder named NLDAS data here, see, and I can just replace the latest one with the previous one here. This is the latest one. If I open it with the Notepad+, so it is showing the, see, you can see the link of every file that has mentioned in the download window, right? So it will start downloading one by one. So you can download one by one, but see, there are 138 files, so you cannot download this by clicking one by one. So what you can do, they also mentioned here the instruction for downloading. If you just click on the instruction, or if you just put your cursor there, and if you hold it, it will show you the other, how to create the account in the Earth data account system, and it will also show you the other instructions. So follow the instruction for wget. So you need another executable that will help you to download these files. If you click on this wget, you need the file format or the executables from here, and then you have to paste the text file in the same folder where the executables of wget is there, or you can just copy this wget executable in your C drive, and then you can make a connection, or you can put the link in your environmental variable, and then you can easily download the required files. So for example, for this tutorial, I have already created the environmental variable based on this wget. So now it is connected with my computer. So here what I can do, I'm just creating a folder here in my download folder, and then the name is NLDAS data, and inside this folder I'm pasting the link of the download files that I have just downloaded in a text format here, and I'll download all the netcedia file here, right? So I'm copy the link of this folder. What I have to do, I have to open and command window here, and then I have to navigate to this folder where I have just put my text file. So how can you navigate? You have to change the directory. It is like Linux system, right? So write cd and then paste it here, and then you can just hit enter. That means, see, I'm inside download folder and then inside the NLDAS data directory here. So now again go to the website and see here they have the instruction: download your data using wget. If you want to download the individual file, you can use this command, or to download multiple data file at once, you have to use this code. Since I already have my text file and I'm trying to download the multiple files at once, I'm copying this and then I'm just pasting here, and then you have to modify. See, it is a generalized command code. So at the end you have to specify your name of the text file. That means go to that directory and then you have to copy the name only. I'm just copying the name, and again open your command window, and then I'm keeping the extension. I'm deleting this one. I'm just pasting here, and then see, you have to modify other things. I'm just keeping it as it is. Ask password. If you just open an account, then you have your own password, and I'm just replacing this portion by my user ID, and it is this for UTA. And then I'm not going to keep any cookies, so I'm just deleting this one. Yeah, it is here. So what I'm just keeping here, the wget, that means it will use the wget executable, and this code, this command now will be run using wget, and if I just hit enter, it will ask for my password. Yeah, so password for this user, I'm giving the password. Yeah, I have already entered my password, and if I just hit enter, it will start downloading the files here in this directory. Yeah, see, it started downloading the netcedia file from 25th of August to 30th August. It is working. No, it is not working. It is not downloading anything because I have made some mistake. Maybe I made mistake there. So I can do it again. I'm going to navigate to this folder. It is there. Again copying this, and then I'm pasting it here. I'm copying my text file, and then I'm pasting the name here. All right, ask password, username, okay, and what I have to do, I'm just deleting this thing up to this point here. hitting enter, asking for password. I entered my password and then hit enter. See, this time it started downloading, because previously I hope I made some mistake in the code. And what it is creating here, see, it is creating the netcd file. It started downloading from the beginning of 2017 and the August 25th. It is downloading from 00 hour, means from the midnight. See, and this file is like 7 megabyte. So we have 138 file, so it will take a while for downloading this. So this is how we can download our NLDAS precipitation. So it is a gridded precipitation system. So our objective is to calculate the basin average precipitation from this gridded precipitation. So I will use today GIS software for computing the basin average precipitation, and in the future tutorial I will use the R code in Windows platform, and then I'll use the same R code in Linux machine. Then it will process this data very fast way, and then I'll show you how to import this NLDAS precipitation into our HEC-HMS model. Okay, so I already have downloaded this precipitation data, so now I'm going to open GIS. Alright, so here it is. This is my basin boundary. I already have developed HEC-HMS model based on this basin boundary, right? So if you have opened these, that means you already have your shape file. I have given you the link in the last tutorial. You can find it there and you can download it. You can open this shape file in ArcGIS. I'm using the latest version of our GIS, which is 10.7. I installed this yesterday. And what do you have to do now? You have to create the 5 basin average precipitation based on this area. So I'm gonna open the property of this study area, the table. If you open the table here, you can see there are 5 objective ID, right? So for our case, what we have done, we just specify this one as subbasin 1, and this is subbasin 2, this is 3, 4 and 5, right? So if I use this number based on this object ID, so what I'll get one precipitation gauge as number 1 here, but it is not synchronized with our previous numbering system. So what I can do, I can rename it, right? So how can I do this? I can just edit it. So if you want to edit it, so you have to open your editor, right? Right click on this and then editor is there. You can put it here and then start editing. And click OK. Sometimes it takes time. Yeah, continuing, it is there. I'm not editing that one, I'm editing this one. I'm again opening here, and then I think we selected the different one, so stop editing and again start. again start editing. You have to select from here, it is sub watershed Sims Bayou. Again, for this time it is that one. So I'm opening the attribute table. Here I'm gonna specify this object ID or anything. So the object ID 1 is it is 4 for our previous model. The object ID 2, it is 5. The object ID 3, it is the same. However, the object ID 4, it is 2, and the object ID 5, it is our subbasin 1, right? Okay, it is done. So stop editing, it is there. Now just open the property again and then go to label. It is already there, so I'm labeling this thing based on this ID. See, now it is there. So I'll show you all the steps in my GIS tutorial. So now what you have to do, you have to open the automatic calculation system. I already have written the code here, you can find it. I'll give you the automatic code. I'm opening this algorithm here. So what I'm going to do, see, I'm just creating a for loop here. All the file I'm putting in a single directory, and for the single file what I'm doing, I'm just making netcdf raster layer from this netcdf file. See, and I'm choosing the variable. I have many variables, and from these I'm only selecting here APCP, that means it is the precipitation. For this case I'm making precipitation raster layer from netcdf file, right? So I'll show you in my GIS tutorial how to make this algorithm, and then once I have my raster layer of precipitation, I have to project it, because I'm downloading the data in geographical coordinate system, and I have the grid. It is 0.125 by 0.15, right? But I have to project it because it is spherical coordinate system. So if I use this coordinate system, I'll have different precipitation on the ground. So what I have to do, I have to project it using a different projection system. It is specific for a certain study area. So for Texas we have a straight plane, or we have equal conic area. So for this case I'm using the Albers equal conic area projection system. So if you just click on this thing, see, it is there. You have to specify the previous file, and you have to specify the output coordinate system. So what it will do, it will project your precipitation raster into USA contiguous Albers equal area conic system. And then from this raster file I'll calculate the zonal statistics as table. So based on the study area, we have 5 sub watershed, right? So it will use the ID. Now I'm using the ID, and it will store this there. It is there, and from this table I need the CSV file. So that's why I'm just converting table into CSV file, and it is storing the data in this directory. It is NWM GIS NLDAS, and the name will be same as the initial file with the extension CSV. So I'm going to show you where it will store the data and where I have stored the input data. It is there. It is in this directory. We have inside the file. See, it is here. If I click here, it is showing the D drive, NWM GIS, and files, and inside files we have NLDAS. So I have this directory here. So I have all the files here. So I have this data from 25th of August to 31st August. That's why we have 168 item here. All the files are in netcdf format, and at the end it will store the data in NWM GIS NLDAS. That means it will store this data here. It is there, and NWM GIS and NLDAS here. So previously I created this, so I'm just deleting these items. Alright, so it will create the CSV file here. So once you have completed this algorithm, what you want to do, you have to validate your entire model. I'm validating this, so it is okay. So if you just click here, run, so it will start running. It will calculate, it will choose one file from the directory. Then what it will do, it will make a raster file for precipitation, and then it will project it into USA contiguous Albers equal conic area. Then from that raster it will use the basin or sub-basin boundary as input, and the raster layer to calculate the zonal statistics. That means it is the areal average precipitation. Then it will make table, and from this table I need the CSV file. That's why it will then convert this table into CSV file, and it will store in this directory. So let's start calculating this. Yeah, I just hit that button and it started calculating. So first it created a raster layer, and then now it is projecting it. See, it is taking time. See, if I use the R code, so it would take less time than this. See, and the rest of the steps are pretty fast, and it is just calculating the next one. See, the projection system, it takes time. So once it is done, it is just calculating the other steps. So by this time we have the two files. So let's see. See, we have 4 files basically here, but in 2 different format. So it is creating the CSV file, and at the same time it is creating the XML file, but we only need the CSV file. If I open one CSV file, what I'll see? I'll see the precipitation here. See, I have the ID 1, 2, 3, 4, 5, and within this subwatershed, the count means I have 36 grid. It is 0.125 by 0.125 grid, and the area is this, and the mean or the areal average for this time period, that means it is the 12, it is at 12 a.m. that means middle of the night of August 25th. There was no precipitation. That's why it is 0 here. And if I just open other file, see, I have the values. These values are in a millimeter. That's why you have to be careful about the units, right? So it is creating this CSV file. So what you will do when it will create all the CSV files including what? Including the XML file. So you only need your CSV file, but you have to delete this XML file. So how can you do that? If you have a 138 or 168 netcdf file, that means it will create 168 or 138 CSV file, and at the same time it will also create another 138 or 168 XML file. So how can you remove the XML file from the directory? If you just delete it manually, it will take longer time, and if you have more than 1,000 of file or more than 100,000 files, so what you will do? So you can use another trick. So I'll show you how to do that. So see, I already have this number of CSV file here. It is there. I'm just copying this. Yeah, I'm copying it, and I'm going to paste. I'm deleting first the existing file. I'm pasting this CSV file and the XML file. So you have to make a folder in your C drive, or you can create any folder on your desktop, and then you can get access from your command window, or since I'm a Linux user, I can use this one here. It is the mobile exterm. I'm using the local terminal here, right? So let's see. So I have to navigate to the desktop. So what I have in my desktop, all the files are there. So I have pasted the files in the CSV_files, so it is there. So you can see the files that I just pasted there. It includes the CSV and the XML file. So now I have to remove only the XML file, and I have to keep the CSV file. If you have several 100,000 files, it is not a matter of fact. It will delete within a fraction of a second. So what is the command? You have to write rm. That means it is the command for removing or deleting. And since I am doing the same thing over and over, you have to enter space and then a dash and then r. That means I'm running the code in recursive mode. And what I'm doing, I'm going to download only the .xml file, not the .csv file. That's why I have to use the wildcard. It is the star, and then you have to specify .xml. That means what I'm just commanding, it is the command for removing the data in a recursive mode. So it will do the same thing over and over, and it will delete only the files that includes .xml. It will delete all the file that includes .xml files. Now if I just hit enter, it will remove it within a blink of your eye, right? Yeah, all done. It is there. So if you have more than 100,000 files, it is not a matter of fact. You can delete it within a fraction of a second. So now you have your, see, you only have your CSV file remaining here. It is there. You have this precipitation, and still the GIS is running, and it is creating the CSV file, and it takes time. We only have 138 or 168 file, and it is taking, so it will take like half an hour, or even it may take an hour. But if you have many files, So it will take like several days to process this NetCDF file to make your CSV file, and then you can process this CSV file to make another time series. So after completing this process, in the next tutorial I'll show you how to process this CSV file to make another time series. So what it is showing here, see, we have the file which is hourly interval file, but inside this file I have the precipitation for every subwatershed, but I need a time series where I have this hourly precipitation time series and I need the precipitation side by side. So what I have to do, I have to read every file for every subwatershed and I have to make a time series. So I can show you what is the steps and how it looks like. So see, it will create this type of time series file. So inside this file I have this thing, I have the time here, date, and this is my precipitation. It is from 2010 to 2017. This is the precipitation. The ultimate goal is to prepare this one, and then I can incorporate this precipitation into my HEC-HMS model. So in my research I have 24 sub-basin. That's why I have created 24 different time series file from this NetCDF file using or following the same steps that I have just described here. So this is how from this website you can download, and then you can, the downloading is still on, or downloading is done. See, downloading is done by this time, but GIS processing is still ongoing. So this is how you can prepare and download your NLDAS precipitation. Right, so this is for today. If you have any question, you can mention it in the comment, in your comment, and I'll try to answer all of your question. So thanks for watching,